Good morning, dear friends. So, today we'll be having a discussion on your organic chemistry paper, that is your organic chemistry 4 for third BSc chemistry students. Okay, so we'll discuss the topic that is the contents of your syllabus, which is soaps, detergents, and micelles. Okay, so So the references for your for these contents, you know that you have been using this textbook right from your first year. So you're using Paula Yukan's Bruce. So the contents of this presentation are from there. Okay, so you can look it up in the books if you want any further thoughts on these topics. Okay, so. mm, so first, what we will do is we split this up into two. So we'll talk about what are soaps, okay, and where are soaps coming from? What is the purpose of soaps? So we'll talk on that. Then we'll move into what we call as the remaining contents, that is micelles and detergents. Okay, so first, we look at the contents. So the contents are fats, oils, and triglycerides, saponification, and soaps. So for now, we look at these 3 points alone. Okay. So the first, what are fats? Okay. Before that, what was the need for fats? What was the need of soap? So since we are discussing only on the topics of soaps, detergents, and micelles, such as cleansing agents. So what was soap basically? Why was soap needed? So you can see that, suppose you rub coconut oil in your hands and you're going to wash it with soap, it goes away. But if you're going to, run it in plain water, it is not going to be washed away. So what's the problem here is water is a polar molecule. So it is not going to solubilize a non-polar molecule. So soaps, they are the bridging agents between polar and non-polar molecules. They have a small polar end and a big, huge, hydrocarbon chain. So this is the reason we are using soaps. Okay, so where are these soaps obtained from? So we have basically obtained soaps from fats and oils. So we need to know what's in fat, what are fats and oils. So fats and oils, they are triglycerides. Okay, so they are triglycerides. So triglycerides are basically esters. Okay, so what is this ester? So a trihydric alcohol, glycerol, it forms an ester linkage with a fatty acid. So fatty acids are long-chain hydrocarbon carboxylic acids. So they are linked as a ester linkage with the trihydric alcohols. Okay. Normally we have simple glycerides where the same fatty acid is there, and we also have mixed glycerides where we have three different, fatty acids linked. So these are the molecules. So you have glycerol here, you have fatty acids here, and you have the triglyceride here. Okay. So these are the molecules, three molecules that are involved in your fats and oils. Okay, so there's the other side of things, like fats are basically obtained from animals. The oils are obtained from plant products, basically corn, soya beans, olives, peanuts. So you have a multiple prospects where you can get oil from. Now, oils are liquids at room temperature, while fats are solids at room temperature, and they are low melting solids. Now, why is this difference that fats become solids and oils are liquids? This is because of mainly only because of the molecular structure. So, fats, they are mainly encomposed of what we call as saturated fatty acids. So, if you're having, saturated fatty acids linked to glycerol, then they become solids because they are closely packed. Okay. Now, in the case of oils, the fatty acids that are linked to glycerol, they are unsaturated fatty acids. So what this does is it does not permit close packing of the fatty acid chains. So because of this, what happens is oils become liquids at room temperature. Okay. Now, it is not completely necessary that, the three, I told you earlier, the three fatty acids linked to a glycerol need be the same. So they can be different. Okay. Now we'll come to soaps. What are soaps? So here you're seeing the structure of fat and oil that has been. This is from your Paula Yukanis Bruce book. Hmm. Okay, so this is the fat. So it is having a closely packed fatty acid molecule. So you can see the red color oxygen group C double bond O's. You can see here. Okay. So here the in the oils you can see that the fatty acid chains are moving away because of the rigid double bonded structure. Okay. So what are soaps basically? So soaps, they are the hydrolysis products of triglycerides. Okay, so oils and fats, when they are hydrolyzed in an alkaline or basic solution, they yield what you call as the alcohols, and they yield the sodium salt of the fatty acids. Okay, now this process we called as saponification. The process is called as saponification. That is, you take the fat or oil and you add 3 moles of sodium hydroxide for every 1 mole of fat that you have taken or oil that you have taken, and you heat it. And along with this, what you do once you start the process of hydrolysis. Once the hydrolysis reaction happens, you can also add perfumes, you can add colorants, you can add dyes to make the color of the soap. Sometimes air molecules are bubbled in to bring in floating soaps and things like that. Now, the simple reaction here is a hydrolysis reaction. So that's what you're seeing here. You can see that fat or an oil is hydrolyzed in the presence of sodium hydroxide to yield glycerol and the sodium salt of the fatty acids. Okay. So some of the common fatty acids that you see in the soaps today, you can see it on the cartoons of your soaps actually. So what you see is sodium linoleic. You can see linoleic acid or things like that. Sodium oleate and sodium stearate. So here you can see sodium stearate is from a fat molecule. It's from a fat. The soap has been produced from a fat because it's a saturated molecule. You can see. So these two are taken from oils. We can simply say that because they are having unsaturated bonds. Okay, so this is your discussion with respect to your fats and your soaps. Okay, so I'll stop here. So we'll have the next session on what we call as micelles and detergents. Okay, thank you.